2.2b, basic differentiation rules and rates of change. So we're going to start off with example 6 because the previous section left off at example 5. This is more of the same, just different, I guess, cases or examples. So for example 6, we're going to rewrite the following functions in order to find the derivative. Now, rewriting can sometimes save you a lot of grief. Here, I basically have a rational function, but it is very easily manipulated to just be just a normal polynomial. So I see that I'm dividing by 6. So the first thing I want to do is I want to split up my terms. So what I'm saying is I'm now going to have x squared divided by 6 plus 3x divided by 6. So I split it up. So now I have two fractions instead of the one. And then, hopefully, you see, if you recall, this x squared divided by 6 is the same as 1/6 x squared. And then the 3 over 6, that's 1/2. And then x. And then now we can just use a regular power function, or power rule, sorry. So y prime is going to be 2 times 1/6, which is 2 over 6, which I can reduce to 1/3, even though I really don't have to, times x, and then I have to subtract 1. So 2 minus 1 is just 1. So that part is done. Plus 1/2 x is just 1/2, right? Because that's like slope-intercept form. The number in front of the x is the slope, so the x does go away. So there's my derivative. And it's really not, this is a very simple function, but because of the division, people think it's harder than what it is. B, same idea, only that a little more simplifying comes in here. For example, I'm going to have to distribute that -3 to make my life a little easier. So I have -12x plus 6x squared, and each is going to be over 2x, right? Because I'm going to split up these terms. So instead of one fraction, I want two. And I'm not done, because that can actually very much be simplified. -12 divided by 2, that's -6. And then x divided by x, they go away. Right? They cancel each other out. That just equals 1. 6 divided by 2 is 3. And then x squared divided by x, that just leaves me 1x. So now this is my function. And if this is my function, my derivative should just be, hopefully you're like, ooh, it's 3, right? The number in front of the x. This is just a constant, so it becomes 0. And that's it. All right, 7. Before doing example 7, I want to remind you of a couple of things with rewriting exponents. I did talk about them in the previous section, but now here I want to make sure that we write them down, I guess. If I have x and x is to a negative exponent, okay, if you recall, I said that that negative just simply meant that now the x is the denominator. Okay, once I write it as a denominator, my exponent is no longer negative. If you kept that negative, then that would be wrong. Same way that if I had something that looked like this, 1 over x to the b power, then I would have to rewrite that as x to the -b. Okay, it goes both ways. Also, oh my goodness, I forgot the words. The roots. So I have, let's say, x to the 1/3. Okay, that means the cubed root of x. And then x to the 1/2 means the square root of x. One more example, and that's when it starts getting a little complicated. Like I have x to the 3/5. Okay, what does that mean? The top is the exponent. So that means x to the 3rd power. And then the exponent, oh boy, the denominator is the root. So this would be to the 5th root. Again, incorporating a negative. So negative, oops, that's not a negative. I just wrote a 3. Okay, -3/5 would just mean that it's the same thing, only 1 over, so 5x cubed. And I'd also like to remind you that you can do them in any order. So like if I had, and you don't have to write this one down, I guess, if you don't want to. But if I had, let's say 8 to the 2/3 power, okay, that means 8 squared and cube root, right? It doesn't matter what order you do them in. You gotta love math. Okay, you could do 8 squared, which is 64, and then you would do the cubed root of 64, right? So that means one number that you multiply times itself, right? So 3 times that number, like, and that's your answer, right? So let's see, 4 times 4 is 16, 16 times 4 is 64. So the cubed root of 64 is 4. Okay, so what did I do first? I squared it, and then I cubed it. Okay, well, if I go and I do the same thing, oh, not there. If I go and do the same thing, but this time I cubed root it first, and then I squared it, I should get the same answer. Okay, so what is the cubed root of 8? So what number times that number gives me 8? And hopefully you're like, well, 2. So 2 and then squared is 4. So do with that whichever one is more convenient to do first. Okay, sometimes some are. For example, 27. Um, eh, okay, here I'm going to want to cube root this first because the cubed root of 27 is 3. And then I can square that and it's 9. Okay, what is the square of 27? I don't know. And then I'm going to have to find the cubed root of that? Forget that. Okay, you want to do it in the order that's most convenient to you. So jumping straight into example 7 now, we're going to find the derivatives. So y prime is, let's see, x to the 4th becomes 4x cubed. The 5, ooh, maybe I should have rewritten that, huh? So let's move this out of the way. And that's what I kind of want you to get in the habit of doing. First thing, rewrite when you see that there's a bunch of exponents and fractions and such. So this is x to the 4th. 5, okay, so I can make this 5 halves. And then the x to the 3rd power is the denominator, right? So to make it not a denominator, I just have to make that exponent negative. And then minus, and then 1 over x squared is the same as x to the negative 2 power. So now that I rewrote it, it should be easier on me to do the derivative. Okay, so I'm going to pick up where I left off then. So plus, oh, but let's see, negative 3 times 5 halves gives me a negative 15 halves. And then x, and then I'm supposed to subtract 1. So negative 3 minus 1 is negative 4. And then minus, oh, but wait, if I'm going to use that exponent negative 2, and I'm bringing that to the front, that negative in front of the x and times that negative 2 is going to become positive. So 2, and then x, and I subtract 1, so that's negative 3 now. So basically this is the answer. You may sometimes, because maybe it's multiple choice, you would have to know what this looks like without the negative exponents. So basically put it back to how it was before. So this would be x to the 4th, and then plus, and then 2 over x cubed. Okay, for b, again, you might want to rewrite, but all the negatives are already there, the exponents. The only thing is the 3 and the 2 and the 2, the denominators. So just keep in mind that this is 1/3, and this is 1/2. And, oh, not that one. That one's okay. The plus is okay. Oh, 1/3, and then 1/2, and then 1/2. Okay, that one shouldn't be too hard to do. And the exponent's already negative. So y prime, so let's see, negative 6 over 3, and then x, and subtract another one. So let's see, minus negative 4 times the 1/2. That's negative 4 halves. Ooh, but that negative is positive. And yes, I know I should simplify, but I am not going to because I'll do it on the next. I'll rewrite it again. Subtract an exponent. Okay, negative 2 times 1/2 is negative 2 over 2, and then x, and then subtract another. And then here we have a negative 1, so I'm going to have to multiply that, so positive, and then x, negative 2, and then the plus 5 is a constant, so it becomes 0. Alright, so negative 6 divided by 3 is 2, and I'll go ahead and write it x to the 7th. Plus 4 divided by 2 is 2, x to the 5th. Minus 1, and then x cubed plus 1 over x squared. Okay. Now, remember what I said that the degrees go down by 1? Technically, the bigger the negative number, the smaller the number is supposed to be. So the rule still applies. Okay. It started off as negative 6. It's ending up as negative 7. Technically, this number, negative 7, is smaller. Okay, so basically that is the most basic of differentiating rules. So now for example 8, we're going to start to find equations. So here we're finding an equation for the line tangent to the curve y equals x squared plus 3 divided by 2x at the point 1, 2. Okay, so to write an equation, I need a slope and I need a point. We're writing an equation for a line that is tangent to this curve. Tangent means that at this point, which I need to write the equation anyway, the tangent and the curve itself have the same slope. So therefore, I'm just going to find the slope of the curve at this point, and that'll be my slope for the line that's tangent. Okay? So they're related in that they have the same slopes. So it really doesn't matter whose slope you use because they're the same. So you find the slope of the curve, and then we have our point, and all you need to do is write your equation. So to find the slope, I'm going to have to derive. But before I derive, I want to rewrite that. So x squared divided by 2x plus 3 divided by 2x. And then when I do that, I end up with 1/2 x, because one of these x's cancels out that one. And then plus 3/2. And see how the x is still in the denominator? Well, I want it to not be anymore. So it's going to be x to the negative 1. So I rewrote it. Now I can find, or I can derive it. Okay, so derive it. So 1/2 x is 1/2. 3/2 x to negative 1. So I multiply by that negative 1, so I get negative 3/2. And then x to the negative 2. Right? But x to the negative 2 is basically means that it's down here, and it's just squared. So there is my slope, but I need to actually figure out what the slope is. So that's where these numbers come in. I'm going to use my point to actually determine the actual value of the slope. So we have x to plug in, so that's a 1. So 1/2 minus 3 over 2 times 1 squared, so it's just 2. So 1/2 minus 3/2. So my slope, or the value of it, now this is the function that gets me my slope, but I actually need to know what the slope is. So my slope is just negative 2 over 2, which is negative 1. So my slope is negative 1. Okay, so again, I repeat, all you need to write an equation is a point and a slope. Well, guess what? I have my slope, and I have my point, and the friendliest way to write an equation is slope-intercept, or no, what did I say? Point-slope form. Y minus y1 equals m times x minus x1. This is going to be your best friend in this class. Now, I can take this equation and leave it in point-slope form, or I can manipulate it and change it to slope-intercept form. It doesn't really matter. Either or is correct. So, y minus y1. Okay, y1 is 2 equals my slope, which is -1, times x minus my x1. I'm forgetting words. And then that's it. This is my answer. You can leave it like this. If this was a free response question, I couldn't say anything about how you left it. This is correct. Let's say it's multiple choice and that's not how they left it. They simplified it some. Okay, so you might have to simplify it some, right? So y minus 2 equals -x plus 1, because I distributed. And then add 2 to both sides. So y equals -x plus 3. So there's slope-intercept form, in case that's what you need. But again, this is perfectly fine unless it tells you otherwise, or it's multiple choice and all of the answer choices are written out in slope-intercept form. Then yes, you would have to figure out what this looks like as slope-intercept form. That's it. Example 9. It's kind of the same idea because it's talking about tangents, but you have to figure out what it's saying exactly. So does the curve y equals x to the fourth minus 2x squared plus 2 have any horizontal tangents? Okay, so a horizontal tangent would mean a line that is horizontal, right? So that means that this line that's horizontal, let's make pretend this is my curve. That means that there is somewhere where my curve and this line touch and have the same slope. Okay, if a line is horizontal, what is the slope of that line? Hopefully you're thinking, oh, well, the slope of that line, right, is 0, which in turn means the derivative needs to equal 0. So we need to figure out if this curve has a horizontal tangent. If so, where? So first off, what we're going to do is we're going to figure out where does the derivative equal 0. Okay? If anywhere. Alright, so we're going to derive y prime equals, so 4x cubed minus 4x. So now what I want to do is I want to see at what x values does this equation equal 0. We have a GCF, greatest common factor, of 4x, so I'm going to go ahead and pull that out. So 4x cubed leaves me with x squared minus 1. Okay, so I have 4x times x squared minus 1. So I'm going to use the zero product property to determine what x equals. Now the zero product property, if you don't recall from Algebra 1, states basically that if I have a something, and we're going to call this a something, times another something, we're going to call that another something. If I multiply these two somethings and they equal 0, then logically in my brain, the only way that they could equal 0 is if one of these somethings is 0 itself, or maybe both somethings. So the zero product property allows me to take these two, I guess, terms. Well, they're not really terms. This binomial and this 4x term, and just make them 0. So 4x equals 0. I can solve for x. X is just 0, right? Because 4 times what gives me 0? X has to be 0. And then x squared minus 1 equals 0. So add 1 to both sides. Square root. So x equals either plus or minus 1. Could be both. That looks bad. Let me draw that again. Plus or minus 1. There you go. So I have 3 answers. X can be 0, x can be 1, and x can be -1. So does the curve have any horizontal tangents? Yes. Where? The curve has horizontal tangents at x equals 0, -1, and 1. And there would be your answer. Okay, last example. Example 10, find the points on the curve. You see the curve, where the tangent is parallel to the x-axis. Okay, so very quick Algebra 1 lesson here, people. So here I have, right, my axes, y and x. Oh look, my x is horizontal. So therefore, if my tangent is going to be parallel to the x-axis, so for example, it's going to look something like this, right? They're going to be parallel. That means they're going to have the same slope, and the x-axis has a slope of 0. So again, I'm doing the same thing, only the question is worded differently, right? I need to figure out where this curve, at what point, does this curve have a slope of 0? Now, when it says the points, um, I need to remind you that a point is an x and a y, not just an x. The x coordinate tells you where, but a point wants exactly like the height and everything. Like the x is where and the y is where. Okay, so where the tangent, okay, so I'm going to have to derive this because I need to know where the slope equals 0, right? So y prime equals 3x squared. 2 times 5.5 is 11x, and then minus 4. And the 7 becomes 0. So here I have 3x squared plus 11x minus 4, and I'm trying to figure out where does this equal 0. So good old-fashioned factoring, yes? I need two numbers. Oh, you know what? I'll list out the stuff I use. Well, actually, let me move this over. Move this over. Because we all learn this differently. So this is A, this is B, this is C. So A times C, so 3 times negative 4 is negative 12. And B is just 11. So I need two numbers um, that multiply up to negative 12, but add up to 11. So there aren't many numbers that add up or multiply to negative 12. I have 1 and 12, 2 and 6, and 3 and 4. I'm looking at those sets. The only ones that could get me 11 are 1 and 12. Now it has to be negative. So one of these has to be negative. So if I make the 1 negative, then 12 plus negative 1, or negative 1 plus 12, does give me 11. So there we go. So back over here, I have x minus 1 and x plus 12. Now, since a is not the number 1, I actually have to take these numbers I found and divide by the number by 3, by a. Okay, so now I have x minus 1/3, and I have x plus 4. And using the zero product property, I have x equals 1/3, and I have x equals negative 4. And so these are my two x coordinates. All I really have to do now is find my y coordinates. And so how would I do that? How would I figure out what the y's are having the x's? And hopefully your brains are working there. And they're like, oh, well, if I want to find y, oh, let me put this down a little. If I want to find y, all I have to do is plug in my x's here. Because if I plug in the x's, it equals, oh look, y, right? So you could do that. All right, so obviously I used a calculator for this. Um, there are easier ways to do this with the calculator. I can foretell you this. I can foresee this example or this problem being a calculator problem because of the math required, although it's very easy to do. So I plugged in 1/3 and I plugged in negative 4, and I got 6.315. As long as I didn't enter it into the calculator incorrectly, you should be right, because I used a scientific calculator. I didn't use a graphing calculator or anything like that. And then I plugged in negative 4 and I got 47. Hopefully that's correct. If I didn't do my math on the calculator incorrectly, didn't miss any parentheses or whatnot. So the answer would be, or answers would be 1/3, 6.315, because in this class you need to round to 3 decimal places, and negative 4, 47. So these are the 2 points. Wow, that looks like a decimal. Let me, negative 4 and 47. So there are my 2 points. Okay, find the points on the curve where the tangent is parallel to the x-axis, and we did. And that's it. Your homework, there aren't any practice problems. You were just supposed to have been, you were supposed to have watched both videos and taken notes.